Best teachers पढ़ाए तो simple लगे everything. Leaderboards and quizzes से
Amazing.
learning हो जाए happening. समझ आएगा तो मजा आएगा.
Vedantu. Learn live online. To attend a free live class, download the app now.
Hello everyone, welcome back. I hope all of you are doing great and a very good evening to everyone. So guys, today as part of the Killer 5 series, we will be continuing with the chapter Continuity and Differentiability. So I hope you guys are aware of this series and you have been following it for a long time now. So let us try to see 5 interesting questions from this particular topic which might be asked in your JEE Mains 2020. Okay guys? So for those who are seeing it for the first time, my name is Shimon Joseph and I'm a math master teacher here at Vedantu. I've been teaching for almost 6 years now, mentoring over 5,000 amazing students like all of you. And like you guys, I too prepared for JEE Mains, JEE Advanced, KVPY, and I cleared all of them. Okay? So with that, let us see what is the schedule like for the coming days. So guys, this is the Killer 5 schedule. So today we are at continuity and the next class will be on application of derivatives. And following that, we have the last week of Killer 5 with sequence and series and statistics and MR. Okay? So Killer 5 series is going to be happening on Saturdays and Sundays at 9 p.m. So mark your calendars and please do watch them so that it can give you access to some very good questions and good concepts. Okay guys, that is the ultimate objective of the series. Now on that note, let us get started and see what is the first question that I have for you. I brought a simple one for you guys to start off the session. This is the first question. So this is completely graphical. I want you guys to think in terms of graphs and understand the meaning of continuity and differentiability in terms of graph. Very important on JEE Mains as well as JEE Advanced. Okay? So let us try to solve this question. What do we have here? We have a function y is equal to mod x minus 1 and they're asking that it is differentiable for all real numbers except which one. So I have to first understand what is differentiability. That is the topic, right? So how do I interpret it in terms of graphs? That is what I want to convey to this question. And I'm sure many of you might find this question a bit simple for the Killer 5. But guys, the concept which I want to convey is over here. Let me put it in simple terms. If you say a graph is differentiable, then the graph has to be smooth and it has to be continuous as well. What do you mean by continuity? I'm sure you guys know that very well. Continuity means in layman terms, you draw the graph without taking your pen off the paper. Are you guys able to understand? So that is how you interpret continuity and differentiability. So when I say differentiable functions are smooth, you should understand that a differentiable function can never have sharp edges or sharp corners in its graph. That is what I will use in this question and we will try to solve it. Okay? So let us get started guys. If you know the answer, please do comment it down. I'll be happy to see your answers. Okay? So first, this function I cannot draw it directly. So I'll use the help of graph transformations. Okay? So please follow this carefully. So first, I will draw the graph of y is equal to mod of x. Okay? So this is a graph of y equal to mod of x. Now, I have drawn mod x. Now I'll convert this to mod x minus 1. So when I say mod x minus 1, this mod x graph will shift downwards by 1 unit. Because from the function, I'm subtracting 1. What am I doing? From the function, I am subtracting 1. So it will come down by 1 unit. So if it comes down by 1 unit, it will be like this. Okay? Are you guys able to follow that? So now, this will be my new graph, which is mod of x minus 1. But is that my final answer? Of course not. Of course not. So what I'll do is I'll erase this so that you guys are able to see it clearly. And let me erase this as well. Okay. So this is my final graph. Now we know that my answer will be modulus of whatever I have here. So mod of mod x minus 1. So when I take mod of this, what happens? What is the operation of modulus, what does it do? It makes whatever is negative positive, and whatever is already positive, I will not affect it. So how do I understand whether something is positive or negative? So if it is above the y-axis, I know it is positive. So this portion of the graph is already positive, and this portion of the graph is already positive. So I do not disturb that at all. But whatever is negative will become ulta. Whatever is negative will become ulta. So I will erase this because it is negative. And similarly, I erase this as well. Are you guys able to follow now? So this is my graph of whatever they have given in the question. Is that clear, guys? Very nice and interesting question. Are you all able to understand it now? So first, we'll figure out what are these points. So at this point, my function is taking the value 0, na? So when will y be 0? Y will be 0 when mod x minus 1 is equal to 0. That means mod x is equal to 1. That means x is equal to plus or minus 1. So this is minus 1 and this is plus 1. And when x is 0, what is the value of y? The value of y is 1. So 0, 1. This is minus 1, 0 and plus 1, 0. So what are the points at which my function is not differentiable? I said not differentiable means the graph will have sharp edges. Can you see this is a sharp edge? This is a sharp edge and this is a sharp edge. So there are totally 3 points where my function has sharp edges when I learn or understand its graph. So at these sharp edges, I will not be able to differentiate the function. Therefore, my answer is option A, which is 0, 1 and minus 1. Because when x is 0, I have a sharp edge. When x is plus 1, I have a sharp edge. When x is minus 1, I also have a sharp edge. What is the reason behind it? Because guys, when you have a sharp edge, now to the left of it, look at the slope of tangent. It is like this. To the right of it, look at the slope of tangent. It is like this. How can I have two different slopes of tangent on my left hand side and right hand side? That is not possible. That clearly tells me that the function is not differentiable. Are you all able to understand it, guys? Clear? So that is how you solve this question. Standalone, this question is a very simple one, okay? But when you look at the concepts behind it, it's a good one to learn, okay? So I hope you guys got it. Please do spend some time, note it down whatever I have discussed, and then we'll move forward to the next ones, okay? So please take it down. I'll give you 5 to 10 seconds pause. You guys can note down if anything is new to you. If not, we will go ahead. We'll go ahead. Okay. So I'm going to close it. With that, let's see what is the second question that I have for you today. But before that, guys, I have attached the solutions for you over here. So please do go through it. The solutions will be as part of your session PDF, which will be available right after the class. So if you want to access it, please download it from the YouTube description or go to the Vedantu app. Okay, that will be beneficial for you. So the second question for all of you is right over here. This is a question based on continuity. Okay, so let's try to understand it. This is a brilliant question. It's nice. Okay, so let's try to solve this. So if you have f of x is equal to so and so, where x not equal to 0 because I don't want my denominator shooting up the function's value, and they are saying it is continuous at x equal to 0. Okay, it is continuous at x equal to 0. Then what is my f of 0? That's what they're asking. So you might ask me, sir, f of x is not defined at x equal to 0. Then how can you talk about continuity at x equal to 0? So guys, you have to go back to your basics. There is something called as removable discontinuity and non-removable discontinuity. So here we have a case of removable discontinuity. So how can I remove the discontinuity? By defining my f of 0 in such a way that my limit at the left hand side and limit at the right hand side of 0 for this function will be equal. So basically what they are trying to say is find the limit as x approaches 0 for this function and make that equal to f of 0. Are you all able to understand that? That is how you break the question. Now let's try to solve it. So I know now my job is to find out limit of f of x as x approaches 0. So basically it becomes a limits question. Are you guys able to follow that? And after I find out that limit value will be equal to f of 0. Why? Because they said it's a continuous function. So limit of x tending to 0 f of x should be equal to f of 0. That is the definition of continuity, na? So let's try to find out the limit here. Okay, it's a good question. Let's see what are the ways I employ to solve this question. Okay, so let us get started, guys. My job is to find limit as x approaches 0, my function f of x, which is nothing but limit x tending to 0. What is f of x? X minus e to the power x plus cos 2x by x square. Okay, so what will happen here? When I put 0, what happens? If I put x equal to 0, I get 0 by 0 form. So you can use L'Hospital, or let's try to do by standard limits, guys. Standard limits is a very nice method. I have told you L'Hospital will work for JEE Mains, but when you are serious about JEE Advanced, and if you are looking for mastering the subject of limits and continuity, you have to be proficient in standard limits. You should know when to apply what. You should be very comfortable applying series expansion and all that. So let's go by standard limits only. So what I'll do is I'll add and subtract 1 over here in the numerator. Okay, so I'll add 1 and I'll subtract 1, and then you already have plus cos 2x. Isn't that correct? Now what I'll do is I'll write it as limit x tending to 0 x plus 1 minus e to the power x minus of 1 minus cos 2x by x square. Okay, are you all fine with that? What did I do? I clubbed these two and I wrote x plus 1 minus e power x as it is, and then I have minus taken outside here, so 1 minus of cos 2x will come. Okay, why did I do that? Because 1 minus cos 2x is nothing but 2 sin square x. Isn't that correct, guys? So that is why I took down this way of approaching this question. Okay, so limit x tending to 0, what do I have over here? X plus 1. Now guys, I will use the series expansion of e power x. What is the series expansion of e power x? Can you guys guess what is that? That will be 1 plus x square by 2 plus x cube by 3 factorial and so on, minus 1 minus cos 2x is 2 sin square x, and then we have divided by x square. So when I open it, you see what is the beauty of this question? Are you all able to visualize what's happening here? So x will get cancelled with this, 1 will get cancelled with this. So what will I be left out with? I will be left out with limit x tending to 0 minus of x square by 2 minus of x cube by 6 and so on. Then you have minus 2 sin square x by x square. That will be minus 2 only, and here I'll have x square. So guys, I hope you all understand that sin square x by x square will be 1, because limit x tending to 0 sin x by x is 1, na? So that's what I did over here. Now this question is very easily solvable. This x square and this x square will get cancelled. This x square and this x cube will cancel, and you'll have x power 1. But x is tending to 0, so whatever comes after this will be a big 0. So I'm left out with minus 1 by 2 minus 2. So my answer is minus 5 by 2. So what is my f of 0? My f of 0 is equal to minus 5 by 2. I hope you guys got it. That is how you solve it. Now what are they asking? F of 0 is 5 by 2? Wrong. F of 0 is not 5 by 2, it is minus 5 by 2. GIF of f of 0. What is the greatest integer function of minus 5 by 2? It is nothing but greatest integer function of minus 2.5, which will be minus 3, guys. Okay, it is not minus 2, it is minus 3, because greatest integer less than or equal to. Okay, so it should be less than minus 2.5. Less than minus 2.5 is minus 3, not minus 2. So second is also wrong. And what is fractional part of f of 0? Guys, fractional part of x always lies between 0 to 1. And 0 is included as well, because for integers there's no fractional part, you'll have 0 as it. So here they have given fractional part of something is equal to negative 0.5. How is that even possible? Of course it's wrong. So naturally the answer should be D, and let's check whether D is correct or not. What is fractional part of f of 0? Fractional part of f of 0 will be fractional part of minus 5 by 2. What is fractional part of minus 5 by 2? It will be 1 by 2. So this is 1 by 2. And what is GIF of f of 0? GIF of minus 2.5 is minus 3. So minus 3 into 1 by 2, which will be minus 3 by 2. And do we have minus 3 by 2 here? Of course. So that is the right answer for this question. I hope you guys liked it. That is the way you solve it. Okay? Are you all fine with this, guys? So this question was an interesting one, and it can be solved very beautifully with the help of your standard limits. By standard limits, I mean application of formulas that you study in limits, guys. So series expansion is another method which is quite useful and powerful. Whenever you encounter inverse functions of sine inverse, tan inverse and so on, try to remember those series expansion formulas. Of course, for JEE Mains it's not needed, but for advanced you can try remembering them. Okay? Perfect. So with that, let's move forward, guys. Let's go to the next question. Take some 2 to 3 seconds to note it down or take a screenshot of it if you learn something new and useful. And with that, let's see what is the next one. Okay? So the next question is right over here. You guys can have a look at it. So this is the next question which I have brought for you. Okay? So this is a question which is again based on continuity and differentiability. So here my f of x is equal to cos pi of mod x plus gif of x. The reason I'm taking these questions is because many students are afraid of this mod, gif and all. I don't want you guys to be under that illusion. It is just a mental picture, guys. It is actually not very difficult. It's pretty easy to solve. And that is exactly what I'm going to show you right now. So please listen carefully, okay? If a question has modulus or if a question has gif, that is greatest integer function, or if it has fractional part of x, don't assume that it is going to be difficult. It is just a mental picture. You have to grow over it. Okay? So let's try to see how to solve this question. So first thing what I do is I have a function f of x and it is equal to cos of pi times mod x plus gif of x. Isn't that correct? And look at all the options. Your options are half, 0, minus 1 to 0, 0 to 1. So what I'll do is I'll restrict my interval from minus 1 to 1. This is the first wise decision you will take. This is the first wise decision you will take, because if you do not restrict your interval, this inside quantity will split into many piecewise defined functions. Are you all able to understand that? That is the beauty. That's how you reduce your solving time. Okay? So I noticed that my options, all 4 of them, revolve around minus 1 to plus 1. So naturally, my thought process goes in such a direction that I would like to see this function in this domain only. I will not exceed that. You can grow more than that also, but it will take a lot of time to solve. You will unnecessarily lengthen your approach. Okay? So let's get started. Now, mod of x depends on whether x is positive or negative. So what I'll do is, I'll take one interval as x lying between minus 1 to 0 and the next interval as x lying between 0 to 1. Now here, let's see what happens. So between minus 1 to 0, my mod of x will be minus x. So it will be cos pi of minus x. And gif of x will be what? Gif of x will be minus 1. Because gif of x in this interval will be negative 1. I'm sure all you guys know that. Okay? And here what will be the function? Here mod of x will be x only. So cos pi times of x only, because x is positive now. 0 to 1 is positive, so mod x will be x only. And gif of x will be what? Gif of x in this interval will be 0. Because between 0 to 1, your gif of x is 0. Between 0 to 1, your greatest integer function of x is going to be 0. Now, let's check continuity and differentiability. So let me write the function again. So this can be written as cos of pi times x plus 1, because if I take minus common, it doesn't matter because it's cos function. Okay, and this is going to be, if I take minus outside from the first one, it doesn't matter because it's cos. So cos of minus x is equal to cos x only. That's why I took minus out, common. Okay, so this is my function, piecewise defined function. I have split it and written it. Now you see it's very easy. I've gotten rid of modulus. I've gotten rid of gif of x in one step. That is the beauty, guys. So it is all an illusion. So once I remove this, it becomes very simple. I'm sure all of you know, in this interval, this is a continuous and differentiable function. And in this interval, cos of pi x is continuous and differentiable because cos of pi x is nothing but cos x. It is nothing but cos x. So only the period will change. I hope you guys understand that. So the continuity and differentiability part will be the same. So this is a very well continuous function in this interval, and this is also a very well continuous and differentiable function in this interval. So both inside these particular ranges, I don't have to worry because both of them are continuous as well as differentiable. So pakka first one is wrong because it is continuous at 1/2. Okay, they are asking what is not true. So first one is true, of course. I know that because 1/2, this is a continuous and differentiable function. So that is true. But I want what is false. Continuous at x equal to 0. That I have to check. Why will I have to check? Because 0 is at the middle. It is at the break of these two functions. Are you all able to understand? So this might be a good point to think about. Second option, because this interval and this interval are connected by 0. So how they are connected, I have to think and then only decide. Let's see the next one. Differentiable in -1 to 0. Between -1 to 0, I said cos of pi times x plus 1 is both differentiable and continuous because it's nothing like but our cos pi x function. Okay, so it is obviously differentiable and continuous. So this is also true, so it is not correct. Differentiable in 0 to 1, of course this is also true because if it is differentiable continuous here, it will be differentiable and continuous here as well in that particular interval. So naturally my option B is correct, but let's try to do that. Let's try to solve it and check it. So how do you check continuity, guys? I want to check for continuity at x equal to 0. So if I want to check continuity at x equal to 0, I have to check at my left hand limit as well as my right hand limit. So let me do that. So let's figure out what is my left hand limit of the function over here. So left hand limit means I'll take this function, and if I put x as 0, I will get cos of pi as my LHL. Okay, let's say cos of pi is my LHL. Okay, because I put x equal to 0 and this is the function on my left hand side to the left of 0, and to the right of 0 this will be the function, and if I put x as 0, I will get what value? I will get cos of 0 as my RHL. So my LHL is going to be -1 because cos of pi is -1 and my RHL is going to be +1. So naturally you can see that LHL and RHL are not matching. So if LHL is not equal to RHL, then definitely the function is not continuous, and therefore at 0 I will have a discontinuity. Since they said continuous, this statement is false. So naturally I will select it because we want to figure out what is not true. That means I'm looking for false statements. Are you all able to understand it, guys? This is a nice question, and the reason I took it is because you have to be very comfortable handling modulus, greatest integer function, fractional part. Don't be afraid of it. Try to solve more questions. Naturally you will get over the fear of it. Okay, so shall we move forward, guys? Let's see what else we have in store. Please copy it down, note down everything, and if you guys are not aware of the reason why I said it will be continuous and differentiable in this interval and in this separately, go back to the basics of differentiability. So whenever you want to prove differentiability of a function, you can directly take one point arbitrary and prove it for the entire interval. So like that, you can take any random point C inside this interval and show that cos pi of x plus 1 will be differentiable as well as continuous. Okay, but I would suggest you not to do that in an exam setup because cos pi x is a continuous and differentiable function. We know that already, so try to use that. So if you want to understand it more clearer, let me give you a simple example. I'm sure you guys are aware of polynomial functions, right? Polynomial functions, you can take it as a standard result that they're always continuous and differentiable. That is a given statement. Likewise, do the same over here. Do the same over here. Getting it? Are you all comfortable now? So yeah, with that, let us move forward, guys. Let us go ahead to the next question. So the next question is right over here. Please do make a note of it. This was asked in AIEEE. AIEEE is nothing but All India Engineering Entrance Exam. It is nothing but your JEE Mains some 14-15 years back. So this question was very interesting. It's a good one. Okay, you guys can probably try it out along with me and we will solve it in a while. The reason I chose this question is because of its uniqueness, and I was quite surprised that they asked this in mains. Okay, so let's see why is it unique. So guys, here you have a real valued function and it satisfies this inequality. And guys, please read the question very carefully, okay? Each and every word matters a lot. Here you have f to be real valued, and that is why you have inequalities. And then you also have differentiable function. Differentiable means what? It is a smooth curve. You can think of it like that. And your f of 0 is 0. Okay, these are the informations which are provided to me. Now I have to figure out what is the value of f of 1. That is the question which is asked. Okay, let's try to break it down and solve it. Now, since they said my f of x is a differentiable function, I can always figure out what is my derivative. So what is f dash of x? I will go back to my basic roots and apply something called as my first principle method. Okay, so what is that? Limit h tending to 0, f of x plus h minus f of x divided by h. Isn't that correct, guys? Now what I'll do is, because I want to apply the given inequality, I will try to put a mod on both sides. Now why didn't I put a mod on h? Because guys, h is positive. Okay, whenever we use this, we assume that h is your positive quantity. Okay, so that's why I didn't put modulus over here, doesn't matter. Now we know that this value, this inequality, let me put the same limit h tending to 0. This inequality, I can substitute this over here. So I will put x as h plus x and y as x. That means this will be what is x minus y? X minus y is the difference of these two. The difference of these two will be h alone, na? So it will be less than or equal to h square, and denominator I have h. So this h and this h will get cancelled. Are you all able to understand that? That's a beauty of linking what is given to what you already know. I tried to apply first principle and I clearly saw that this term, if I put modulus, can be completely related to this one. So f of x is nothing but related to this one, and y I'm taking as this one. So what is that less than equal to? That will be less than or equal to x minus y the whole square. What is x minus y? X minus y will be h, because x is x plus h and y is x. So x minus y will be h alone. So h square divided by h. H and h will get cancelled. You'll have limit h tending to 0 of h. What is that value? That value is 0, guys. It's a standard limit, na? It's a direct limit, direct substitution. So it is 0. So I have modulus of f dash of x is less than or equal to 0. How can modulus be less than or equal to 0? Can modulus be negative? Of course not. So what is the only possibility? The only possibility is modulus of f of x derivative is equal to 0. That means f dash of x is 0. That means f of x is a constant function. If f of x is a constant function and f of 0 is 0, then f of 1 also has to be 0, because it's a constant function. Therefore, option B is correct. Good question. Very interesting, right? So very unique way of solving. I'm sure you guys would have enjoyed it, because I personally did, and I didn't expect this to be asked in JEE Mains, but it can come, guys, because as I said, the level has become good these days, and you might expect question like this probably in integer type, numerical. You never know. So be prepared for it. Okay, so please note it down, and if you have any doubts, do let me know in the comments, or you can even let me know in the chat. Okay, Perfect, guys. So with that, let's move ahead. I'll give you probably 5 to 10 seconds to note it down. I'm sure you guys are aware of the fact that Vedantu has won the Google's User Choice Award recently in the month of November. And thanks to all those who contributed and voted for us. You guys have immense faith on us. That is super awesome. And as always, do like, share and subscribe to our channel. Do let me know what you felt, guys, and if you have any particular requirement, that also you can comment it down. And keep working hard. All the very best. Let me know how it goes. Okay, bye bye, guys. Take care.